this video, we're going to look at family resemblance and learn about how your father and your mother each contribute to your genetic makeup. Here's a question. How can a single bad gene make you smell like a rotten fish? Let's talk about it. So, can a gene be cruel? Well, of course not. But if one could, consider this candidate. In humans, there is a gene for an enzyme called FMO3. It's flavin-containing monooxygenase 3, and it breaks down a chemical in our bodies that smells like rotting fish. Some unfortunate individuals inherit a defective FMO3 gene, and they can't break down that noxious chemical. Instead, their urine, their sweat, and even their breath excrete it, and it causes them to smell like rotting fish. Ugh. Worst of all, because the odor comes from within their bodies, they can't wash it away no matter how hard they try. This is called fish odor syndrome. And this disorder often causes those afflicted by it to suffer ridicule, social isolation, and depression. There have been about 200 cases of fish odor syndrome reported, but researchers suspect that it may be underreported because many people with the symptoms don't seek help. Currently, there's no cure for the disorder, although there are a few ways of reducing the odor, such as reducing consumption of foods like eggs, fish, and some meats that contain certain chemicals, including sulfur. And think about it. Individuals who are born with this malady, beyond their own suffering, there also looms this scary question of, will I pass this condition on to my children? They might also wonder how they came to have the disorder, particularly if neither of their parents suffered from it. Fortunately, most of us don't have to worry about fish odor syndrome, but we do wonder about many other inherited traits that we may or may not pass down to our children. So where do we begin and our parents end? In many cases, the answers to questions about heredity are simple. Recall from Chapter 6 that sexually reproducing organisms inherit one copy of each chromosome from each parent, so that they carry 2 copies of every chromosome in every cell, except, of course, their sex cells. And humans, for example, have 23 pairs of chromosomes, which gives them 46 individual chromosomes. So at each location, which we refer to as the loci or the locus, singular, on the 2 chromosomes of a pair is the same gene. At each location on each of the 2 chromosomes of the pair is the same gene. So there's one copy from the mom and one copy from the dad. And as we noted even earlier in Chapter 5, each of the 2 copies of the gene is called an allele. All right, back to this fish odor thing. The gene for FMO3 is on chromosome 1. There's a normal version or allele of the gene for FMO3, which most people carry, and there is a rare defective version that is responsible for fish odor syndrome. And as long as a person has at least one normal version of the FMO3 gene, he or she will produce enough of the enzyme to break down the fishy chemical. But if a person inherits 2 copies of the defective version of the fish odor gene, one from each parent, that person will inherit the disorder, making this disorder recessive. When it comes to having children, there is a bright side at least. Although individuals with fish odor syndrome carry 2 defective copies of the allele and will pass on at least one set of the bad instructions in every sperm or egg cell that they make, their children won't necessarily inherit the disease. As long as the other parent supplies a normal version of the FMO3 gene, the child won't have the fish odor syndrome. The unaffected children, though, will carry a silent copy of the fish odor allele, and if, when they have children, it comes together with another defective FMO3 allele from another person, that fish odor trait will be expressed. And in this way, some alleles can exist in a population without always revealing themselves. Very stealthy. So as we go through this unit, we will explore how heredity works. And we'll find that inheritance follows some simple rules that allow us to make sense of patterns of family resemblance, such as things like facial features or hair texture, and even to predict the likelihood that an offspring will inherit a trait. We'll also examine why the behavior of some traits is easy to predict, while many other traits have less straightforward patterns of inheritance, yet still can be studied experimentally and yield relatively predictable patterns.